Okay, hello, you're welcome to my channel. In this video, we want to find the antiderivative of this function, right? Okay, great. This is the day 19th, all right, of our 30 integrals in 30 days. And our previous videos, okay, I've told you that from the day 21st, 22nd, 23rd, 24th, 25th, okay, I'll be solving integral questions and they'll be coming from you, okay? So I want you to put your questions in the comment section, right? Integral questions only, because that's what we are doing, so that from 21st to 25th I'll be covering that for you guys. All right, okay, great. So let's just go ahead and look at this. Well, this is simple because there is a standard technique that you can make use of whenever you give an inverse tangent of some function here and the function isn't really that crazy, right, provided you can work with it. Okay, so let's just go ahead and try this. One thing about integral questions is practice. That's one thing, and when you practice a lot, you will get to know how to start solving some kind of problems. All right. Okay, so look at this. I'm going to use the integration by path technique. All right, and this is it. I'll first of all put the d here and the I here. Right. This works pretty much like the formula. So I'll put the addition sign, the negative sign, the addition sign, the negative sign, and as much as I want. But most times we don't even go that far, right? So the next thing is to decide which function you want to integrate and which function you want to differentiate. Well, here the choice is, making such a choice here is very cheap because we want to find the antiderivative of 10 times something, right? This 10, since a constant multiple, it doesn't really matter because we can put it out front and just focus on this function, and that will be the integral of tangent inverse. So if you are choosing to integrate tangent inverse, it's just like answering the entire question inside the solution, right? So which doesn't make sense. So that means you just have to differentiate inverse tangent, right? So we go ahead with the inverse tangent of 2 over t. Okay, that's nice. And then that means we just have to integrate 10 here. Okay, great. There is no point for these ones. Let me just clean them up and put the negative sign here because we may need some space. So the derivative of tangent inverse of 2 over t will be, now if you differentiate this over the t variable, take note over the t variable, this will be, now when you have a function, let's say inverse tangent of some function, let's say some function of x, all right, the derivative will be of that function, right, will be 1 over 1 plus the function squared of the square of the function. So the function, you square it, all right, okay, and then you multiply it by the derivative of that function. All right, this is by using the chain rule at the same time. So that means this function is just 2 over t. So we are going to differentiate this and then multiply by the derivative of this inside. So the derivative of that will be 1 over 1 plus the square of what we had here. That will be 1 over 1 plus the square of 2 over t. That will be 4. The square of 2 is 4. Then the square of t will just be t squared. And we are not done because we need to multiply it by the derivative of that inside function. So what is the derivative of 2 over t? Well, it is just negative 2 over t squared. So I'm going to multiply this by, this is 1, negative 2 over t squared. So let me give a little room here, right? Negative 2 over t squared. Okay, very nice. So we are done with that. So we need to go ahead and see how we can take from here. Now we also integrate this, the integral of 10 over the t variable will just be 10t. Okay, so you notice this differentiate, you put down the function first from here, you differentiate it. This integrate, you put down the function first from here, then you integrate it. Then when we're done like that, we have to multiply this diagonal. All right, multiply this one with that diagonally. That means we're going to have 10t times this. That will be 10t times the tangent inverse. So you notice that this is not just 10 times. So 10t times inverse tangent of 2 over t, right? Maybe I can use x just to avoid it, to take care of the confusion. And then the next thing is to integrate the product of this last row, right? Keeping in mind the signs as well. So the product of this last row, we are going to integrate it. I'd like to put it down here. So this will be negative times negative, all right? Okay, so let's take it bit by bit. So as I said, after multiplying the diagonal, you you integrate the product of the last row. So that means we're going to have to multiply the last row and then integrate it. Okay, so you take it bit by bit. This is negative times this negative, this times this positive 10, right? So negative times negative 2 times positive will become positive. That's the first thing. The next thing is 2 times 10 will be 20. So since it's just a constant multiple, I can put it out front. Okay, now at the top, what we have left is just 1 times t, which is just going to be t at the top. And then at the bottom, take note, this is t squared. So you multiply t squared with this one, that will become t squared, right? Because you multiply it by 1 to just be itself. Then you multiply t squared by 4 over t squared. We will just have 4 left because this and that will cancel, right? So this is going to be 4. Okay, that's it. And then we put the dt over here because we are going to be integrating over the t variable. All right, great. Now this is where it's going to be very interesting. This is 20, right? This 20, I can rewrite it as 10 times 2. So let me put the 10 here and then put the 2 here. 10 times 2, or 10 times 2 is what? 20. The same thing, right? Notice 2t. If you differentiate this bottom, the derivative of this bottom will give us 2t, all right? That tells us that this will become 10t times the inverse tangent of 2t, all right, plus 10 times the ln, or it's say the natural logarithm of t squared plus 4, and we are done. We add an arbitrary constant, and this right here is 8. How did we get this part from here? Well, 10 times, as I said, the antiderivative of 2t over t squared plus 4. If we differentiate this bottom, t squared plus 4, we are going to have 2t, which is just the numerator. That means the result will be 10 times the ln of the denominator. The reason is, if you are integrating a function, and the function is of this form, f prime of t divided by f of t dt. That is to say, if the derivative of the bottom gives you the numerator, then this will become ln of the denominator, right? This will become ln of the denominator. So the derivative of the denominator gives us the numerator. That means it will become ln of the denominator together with this 10 out front, that is 10 times that, and then we add an arbitrary constant, and this right here is the antiderivative of this function. Okay, great, right? Please remember to put your integral questions in the comment section. Thanks for watching. Please share this video.